Okay, so this is my talk. I work at a company called Douglas Connect, which is a small company in Switzerland that works in toxicology. And we built two of our products in Elm. And I want to talk to you a bit about my journey that brought me to Elm and what I like about it and about this kind of languages. So one idle Sunday this summer, I made this little map of like programming languages that I know and I like and I experienced at some point in my life. So I started out in the non-garbage collected deserts in C and C++. Then I worked there for a while, and then I started to go more to the object-oriented mountains, to C# mostly. I did a bit of Java as well. I mean, I think for most intents and purposes they're very similar. There were a couple of things. So I wrote some multi-threaded Windows desktop applications for statistics, basically. And there were a couple of things that I really liked about it, but then over time there were also these things that started to really annoy me. Two-way data binding was very nice in like theory, but in practice it led to very big problems in complex code. Object-oriented design patterns are cool and they allow you to think a certain way, but I often found that they are a kind of a distraction also. I then went into the dynamically typed swarms. I call them swarms because I think it's a bit hard to build big projects in them in a solid way that like endure for a long time in big teams. I did some Python work. I'm still using that at the moment quite a bit. JavaScript, I started to build web frontends in JavaScript. And I had this problem that refactorings are really error prone. I think that was one of my main pain points. Whenever I changed something in JavaScript, you have to be really diligent to make sure that you capture all the usages and make sure the changed data structures are caught everywhere. And then I had a friend who was telling me about Haskell, which is part of this group of the functional forests, I called them. So we have languages like Scala, which is like a hybrid language, and F#, like they're somewhat object-oriented, somewhat functional. And then we have PureScript and Haskell and F#, and PureScript and Haskell and FSAR and in these kinds of languages. And then we have Elm up there in the forest. And I think that Elm is a very nice language because it's from this entire family of languages that are all really cool and powerful, I think, and a very good thing to learn as a programmer. I think that Elm is the most approachable, and it's very useful for building web applications, and that's why I want to talk to you about it. Let's jump in and have a look at what Elm, the elevator pitch, would be. So what is Elm? Maybe a quick show of hands. How many of you have done at least a little bit of Elm coding, like a tutorial or something like that? Okay, a few. How many of you like have heard a lot about Elm, or like it has come up on their radar? Okay, more. Cool. So a lot of you will probably already have like this idea what Elm is. It is a statically typed language. It's purely functional, so it's not object-oriented, it's not imperative. It compiles to JavaScript. It's made for building web apps with it. The big thing, I was thinking about making this blink or something like that, right? It's no runtime errors. If you've ever written web apps in JavaScript, I think this would be immediately appealing to you, right? So no runtime errors ever. And it's very easy to learn. It's really a very approachable language, and Evan Saplitsky, the creator of Elm, made it a priority that, I think we heard it in the talk before here in the programming languages track, where it was about Rust, that the error messages from the compiler of Elm were an inspiration to make the Rust error messages better. I think that is true for a lot of languages nowadays. So Elm error messages are like the gold standard, I think, by now for how nicely a compiler can tell you about what goes wrong. The syntax. So here we have JavaScript syntax. JavaScript is one of the languages that, like a lot of languages, come from the C family of languages syntax-wise. So it has these curly braces and like semicolons on the end of the lines and stuff like that. And Elm is from the ML family of languages, both syntactically and also from the concepts it uses. And initially the syntax looks weird. But if you arrange it in the right way, then you see that it just gets rid of the clutter. So this is Elm. So if I switch back, basically all these weird things, right, we just take them away. The curly braces, the semicolons. Yeah, it was nice in the 70s to have that to write parsers a little easier, but we don't really need those, right? So usually you would align it more like this. So you have a function declaration that is, it's clear that it's a function because there are other tokens before the equal sign on the top level, and then it evaluates to this thing. We don't need return statements. And then below you have function application. So we have a value called result, and we assign the result of using the function multiply numbers with these two operands. And it's statically type checked. So instead of here some weird type coercion happening when you call this function with an integer and a string, here this would be a compile error. The compiler would say, no, this doesn't work. You need to use two numbers when you try to use multiplications. Okay, you can, if you like, use type annotation. So this is a way of specifying what these arguments are. They're a bit unusual if you've never seen an ML language, family language. So the way this works is the last thing in these type annotations is the return type of the function. So in this case, multiply numbers is a function that takes two integers. The first argument is an integer, the second argument is an integer, the thing it returns is an integer. And below we also give a type annotation to the single value result, right? It's also an int. Okay, that's easy enough, but it's good to know that type annotations in Elm are entirely optional. So you can never in your program write any type annotation, and it will be exactly as strongly typed as if you write type annotations. A lot of programmers like to use type annotations because it's a kind of documentation, and the compiler can tell you when you make a mistake right at the first point where you make the mistake, and not then at some point later in the program when it's maybe a bit more obscure what's going on here. Here's a bit more of like what the language looked like. This is a simple type alias for, we define a type called person, and then we define a function calculate age that takes an integer and then this person record or a structure, and it returns an integer by calculating the difference between the current year and when the person was born. Okay, let's talk a bit about pain point that Elm addresses, because I think that that's a good way to think about the language, especially because it compiles to JavaScript, and a lot of the use cases that you would use it for is to replace JavaScript, basically. One of the things that I always found is, I said that before, code in dynamic languages is hard to refactor correctly, right? And because it's hard to refactor correctly, we have to really take care that we don't make any stupid mistake. Like if we add an argument to a function, that all the places where we call that function, we make sure to pass in that argument and stuff like that. If we have these problems and we have to take care that we take care of doing this correctly, we do it less because we're afraid of changing it and we don't want to deal with it right now, and which leads to lower code quality. So if this is a big project that several people are working on, over time this can lead to a lot of, like, just a lot of refactoring is not done, a lot of lower, like the code quality becomes lower, and then the development speed goes down because you have all this cruft that accumulates and you never deal with it. And when you do refactorings, they often introduce bugs and crashes. Now in Elm, everything is fully typed. So even if you give, as I said, no type annotations ever in your project, the entire project will be fully typed, and the compiler checks that all types match, even between modules and packages and everything like that. There's also no any type. So if you know TypeScript or Flow, they have this kind of escape hatch of any. Elm doesn't have that. Elm doesn't have any. It doesn't also have, because it's not an object-oriented language, so there's no type hierarchy where everything like derives from object or something like that. There's just a fundamental difference between types, and the compiler will make sure that you don't cross these. Okay, so records, we briefly showed those before. We define one of those called programmer, has two fields. One is named, which is a string, and favorite language, which is a string, and then we create a new value with that type, or of that type, name Daniel, favorite language Elm. That's nice and easy, but then Elm has a very nice feature that is called union types or sum types. This is something that I wish basically every modern language had, and I'm really sorely missing this in languages like Java and C#. if you look at it like that, so it's often used for cases like where you have something like a status, right? So there's like two possible values this status can have. It can be either pending or it can be completed. And then maybe we have a record called task that has a name and then a value of this type. So far so good, right? So far this looks like an enum, maybe that you know from Java or C#, right? Okay, so what's so special about this? The special thing about this, or maybe first quickly how we use it. So if you ever want to use a value of this type, you have to do pattern matching, and Elm does exhaustion checks. So it will check, did you, at every use of a variable of this type, did you cover all cases? So if you want to use a value of this type, then you cannot just like grab into, like look at it. You have to say, there's a value of this type. I give you all the cases that this can possibly have. If I just write the pending state here, then the compiler will complain and will say, hey, you didn't cover all cases. So if I give it the completed state as well in this function that turns this status value into a string, then this is how you would do it. You say case status off, and then you give all the possible cases that this status variable could have. The thing where it gets interesting with union types is, what if some of the states have data attached, right? So maybe, for example, we would have a progress report, right? So we introduce a new state that's running. I'm sorry, I forgot that the running state here. So between pending, there should be a running state as well as completed and failed. And then we have the current item and the number of items. And then maybe we would like add these fields to the task, right? So we basically have our enum-like thing called status, and then we have we would store this information somehow now in the task, and we also have this failed state, right? So when we're in the failed state, maybe we want to store a list of error messages that occurred during the task, and again, we would need to store these in the task itself. The problem with this is that, and these kinds of things in data modeling, I think they come up all the time, right? Where we have different states and some of them have additional like payload data that we need to take care of. But in most languages, this is all you can do. You have some kind of an enum that says like, or like this state type that says, okay, which state are we currently in? And then you have a bunch of additional data that you want to keep track of, and you have to pack these into some other data structure that you keep around. The problem is the errors, like variable, for example, it only really makes sense when we're in the failed state, right? I mean, sure, we can have the empty field around lying there, but it doesn't really make so much sense. And there is this great thing that also was mentioned in the talk about Rust, that's a really important design philosophy, I think. If you can make invalid states irrepresentable in your code, that's a very, very useful thing to do. So what this means is, if you can write your types so that an invalid state cannot even be expressed in the program, then you don't have to test for it. It cannot occur and it can slip through your code in practice, and it can never end up in a bug in production. So here we see the real power of union types. Basically, each one of these enum-like things, right, of these different cases that the type status can have, like pending, they can have payload data attached. And so running, for example, has 2 ints that it carries with it, and failed has a list of strings that it carries with it. And so if we want to, for example, create a value like here in the middle in val1, where we create the value of this running, of this type status, but in this case we want to use the running type value constructor, then we always have to specify these 2 integers in this case, right? Because the type definition says that there's 4 different kinds of things that a value of this type can have, and if it's running, then you need to give me 2 integers. And this means that our task struct type, our task record type, only needs concern itself with the name and the status, right? And the status, depending on which of these values it actually has, will have different payload data attached. So here's how we do pattern matching when we have payload data. So again, this is the getUI string function. It takes a status, it turns it into a string that we can display in the user interface. The first case and the completed case are the same as before, but now we have this running where we say, okay, so we want to give these 2 integers that we pass on in the running state. We want to name these current and total, and then we turn the whole string into the whole thing into a string that basically says this is number 1 of 10 or something like that. And in the failed case, we want to give an error message that joins all the entire list of error messages and puts that into the string. And this is a really powerful construct, right? Together, these types, things are called often algebraic data types when a type system has some types. And I think that this alone is a very nice feature that allows to model a lot of cases that are really useful. This pattern matching is the only way that we can get payload data out of these value types, right? So for example, if we wanted to access the list of errors, we have to pattern match and say in the error case, then I get the list of errors. In all of these other cases, I don't have that data even available, and I cannot accidentally access it or use it in a wrong way. Briefly to mention it, for some reason my syntax highlighting broke down on this slide, and I think one or two other ones. You can have polymorphic types, aka generics. So this is how you would define a binary tree type, basically. You have a type variable now called element type. And again, this is a union type. Either it's a leaf, then it has whatever type you instantiate this with, or you have a node type and then you have two payload data pieces. Both of these are, again, binary trees. We need the parentheses here to indicate to Elm that these are like basically positional arguments and there's like two of them. Otherwise, it would parse it differently. Okay, basically that's it. Then there's a sample of how to create a leaf only or how to make a small binary tree out of this. Other pain points, right? Undefined is not a function or null reference exception. When I was programming in C#, I think about half the major bugs that we have were null reference exceptions. And often this is the case of just a big code base grows. You had a piece of code that had this assumption that this part can never be null, and then the code changes and it grows and grows and grows, and sometime later this assumption is no longer valid, and you end up with null reference exceptions in production code. Elm doesn't have that. Elm doesn't have the concept of null or undefined, and this kills a whole family of bugs. But then, if you don't have null, right, how can you represent missing values? Well, we use union types for that. So there's this type called maybe. So if you know Scala, that's what option is in Scala. Basically, it's either nothing, and then we don't have any payload, or just, and then we have like one value of whatever a is defined to be. And so here we define two different values. Again, val1 uses the nothing constructor, and val2 uses just, and then we need to give it the actual content of it, and then it's a maybe of int. The first thing where we use nothing, the type that I wrote here is actually more specific than it would really be. So because Elm, if you just leave it to itself, would just say, okay, this is a maybe of a, because nothing can be anything, which is philosophically a bit weird, but whatever. But basically, it would infer that the type can even be more generic, and you can always give it a more specific type if you like. What if we need error information? So we saw this if you went to that in the previous talk. The Rust language has picked up this same concept of a result type to represent operations that can either succeed with some data type A or fail with some other data type B. Very often the error type is maybe just a string or a list of strings. Like here we use a single string, and in the OK case, in the examples down here, we use an integer. But of course these can be arbitrarily complex data types, right? This is a very nice thing, because again, every time you use a value of this type, you have to say, what do I want to do if this is the OK case, and what do I have to do if this is the error case? Another interesting thing about Elm is that all values are immutable. So as opposed to Rust, where this is like kind of an opt-in thing to make variables mutable, in Elm everything is mutable. So you cannot assign to the same variable a new value. So they're more like named values than like what you would think of as variables in programming languages. And you cannot like dot into values. Like for example, here we define a value of this programmer type. There's no way you can just change a property or a field of this record. And now maybe you think of like, how the heck are you ever going to program if there's no mutable values, right? Which is a fair question. The thing is, what you do is you create new values, right? So for example, here when we want to create a new programmer B that has all the values, all the fields set to the same value as programmer A, just the name be different, then this is how you would do it. There's like this special syntax where you use the record curly braces again, and then you use a vertical bar before you specify what is the value that you want to base it on, and then you give the fields that you want to change and give the new values for that. I'll come to how to actually write useful programs with an immutable language in a second, right? So keep that thought if you have it. I just want to finish a few other things about the language first. One of the side effects of this, by the way, is we can't do loops in Elm, right? So for loops, they require a counter variable, right, in other languages. We can't do that in Elm because we have no mutable values. The solution for this particular thing is to use either map or fold, which most of you probably know more under the name reduce, or use recursion instead. But yeah, this is a bit weird in the beginning, but you get used to it. Okay, we're almost through language-like features, so we can look at some code in practice and how this all plays out. But one thing that you need to know still is that Elm is entirely pure. So this means that all the functions are pure, and none of the functions can have side effects. There's two small caveats, which is debug log, which writes to the console, and debug crash, which just crashes your application for debugging purposes. But other than that, it's like every function is idempotent. So this means that if you call the same function again with the same arguments, the same thing will come out of it, right? So how do you get work done in a language that's immutable and all functions are pure? Sounds weird. Elm comes with a small runtime, and there's also no direct JavaScript foreign function interface, so you cannot just call out into JavaScript. But the thing, how this works is the Elm architecture that we'll take a look at in a second. But just to explain a bit more in detail, maybe how this thing with the pure, what this means, that every function is pure. In Elm, because there is no way to just execute arbitrary JavaScript or perform any side effects really, this function that I have up here, add numbers, it will always evaluate to the same value, right? In JavaScript, as you see below, you could do weird stuff. You could like have a global variable that uses this, that may, in this case, for example, is a counter that we increase. And so calling the same function again with different arguments actually leads to different results, right? Or if you have a library and you just call this function, it might actually just do an HTTP call and like transmit your data somewhere else or whatever. In Elm, you have this guarantee that this can't happen. There's no side effects that you can perform in the language itself. Plus side makes testing super nice. Functions that are idempotent, that always return the same values when you give it the same arguments, they're super nice to test. And you don't need this kind of mocking that you sometimes need in other languages. And thanks to static typing, most of the unit tests can actually focus on the logic. Like in JavaScript, you test a lot of like, okay, but what if I pass in null here? And what if I pass an integer instead of a string, and these kinds of things. These are kind of boring properties that the type system takes care of. It also makes the refactorings a lot more safe and fun, because the compiler can check all these things for you and then can tell you if something goes wrong. So now, how to write actual programs in this? There's something called the Elm architecture, and this is basically the gist of how it works. You give the Elm initial start program that that you use to create an Elm application 3 functions. You give it the init function, the update function, and the view function. The init function basically creates the initial model. This is basically a single big record usually that contains the entire state of your application. From this is then passed into the view. As you see here, the signature of that function is model goes to HTML of message. And so what this does is it uses this model type that you created before, this value, and it turns whatever this state representation is that you have of your application into something that can be displayed to the user. It does this very similar to React, if you know that. So it has a virtual DOM kind of library, and you build up basically a virtual DOM. The Elm runtime does the diffing to you, and then changes the DOM representation that is shown in the browser to the user. The user does something, and whenever the user clicks something, for example, a message is sent back to your update function. The update function gets this new message that just happened, it gets the model as it is currently, and it outputs the new model as it should be, and a couple of commands if you like. So commands are these things that go to the Elm runtime, and they are the things that actually are allowed to perform side effects. So a command is basically just a way of describing, please do this HTTP request for me, and then when you're done, like, come back to my update function and send me the request, the result of that request as a message. This is basically all there is to it, right? So this is the Elm architecture, and it's this unidirectional cycle of doing user interfaces that has been very popular also in the React world with the Redux library. The Redux library took its ideas and its inspiration exactly from the Elm architecture. The thing is, this looks maybe a bit weird if you're used to other UI paradigms, but the really nice thing about this is that it's super easy to test, and you have it all laid out, because the only place where some state in your application can ever be modified is in the update function. So I think that this is a really powerful model. The model that you create in this initial init and then update continuously in your update function is a single source of truth. So in a lot of JavaScript applications, when the old way, right, the jQuery way, where we stored data in the DOM itself, you had these kind of race conditions where several components maybe tried to update the same value in the DOM at different times. This cannot happen with the Elm architecture, because there's only one place where it gets updated, which is the update function. And this value that gets out of the update function, the new model, is the single source of truth for your entire user interface. Visual elements are then created from this current model, right, as we saw with this view function. The apps are always well structured because they all follow the same paradigm. And you can easily replay UI sessions, because you just have to log basically all the messages that were sent to your update function. And then you can go back and forth, and you can serialize them and do undo, redo, and stuff like that. Okay, before we look at actually some live demo of how this all works, a quick explainer of how view functions work, because otherwise you will spend all the time on the next demo looking at what the heck this weird view function thing is. Basically what you have here is, like, this is very similar to what React does with whatever it does, with these div functions that create virtual downloads and stuff like that. In Elm, this is no special syntax, right? So this is not like JSX or so that was like patched onto JavaScript. This is just normal Elm code. And all of these functions that you see here, like div and button and so forth, they're functions that create a single DOM representation node, and they always take two lists. The first list is the list of attributes. So as you see in the first example with the outer div, the first list has exactly one element, which is whatever happens when you call the function class with the argument of the string of counter. And then you have three child elements. That's the second argument to the div function, is another list of the children elements. And in this case, we have a button, a div, and a button, and it corresponds to this HTML that you see below, right? Again, in the beginning, this looks a bit weird. It takes a few days maybe for your eyes to acclimatize to this particular syntax. But once you get into it, just like with the ML syntax, it becomes really very obvious and a very straightforward way of encoding this, and you actually can read it very quickly. Okay, demo time. So let's switch over. Here I have an Elm app running live. That was created with Create Elm app, which is maybe very similar to Create React app, if you know that. And here I have the Atom editor with the Elm plugin installed. One of the nice things that you see immediately, I hope you can, maybe, I don't know if you can read this, but you have this these type annotations here on hover, right? They're a bit too small maybe. Should I make this? Can you read this in the back? Is that okay? Should I make it bigger? It's okay. Okay, so let's go through this. Basically what we have here is, here we define our model, right? This is a record that has one variable called counter, and it's of type int, right? It's a simple demo app. Then we have the init function, and this creates a tuple. So I didn't cover the tuple syntax, but this is basically just like within parentheses, separated by comma, you can have tuple values. This is a two tuple. The first value is of type counter model, and the second type is of type command of counter model. So this is basically, if you want to tell the Elm runtime to do something for you, like an HTTP request, this is basically what you would use for that. In this case, the thing that we want to do initially for the model is we want to create a new record with a field counter set to 0, and for the command we just want to do nothing for now. Then we have counter message. This is the message type, and the message type is a really nice use of union types because it enumerates all the possible things that can happen in your entire application. So if a colleague hands over an Elm project to me, I just need to look at the message type, and I know immediately all the things that can happen in this application. And then I look at the update function, and then I see all the state transformations that actually happen in this application. So here what we do is we get the message that was sent to the application, to the update function. We get the current model, and then we pattern match on the message that we received. And if the message is increment, then what we do is we create a new tuple, and for the model value of the tuple, we use this record update syntax that I showed before. So we update the current, we use the current model as the base, and then we set counter to model.counter plus 1. Right? So we increment the counter field in the record. For command, we still use none. We don't want to do any HTTP requests or something like that. And then for decrement, it's basically the same thing, but with -1 here. And then here we have this view function that we just saw before that basically just takes this model and renders it. So here you have the text where it renders out the string as a child node of this second div, of this nested div. And what's maybe interesting is this thing here, the onClick decrement. So onClick is a function that will render an attribute, and but what you pass into this onClick is not a function, which is maybe what you would expect from a functional programming language, but it's the actual message value that we want to receive when this happens. So when the user clicks on this button, what we would like to receive in our update function is the message that was declared here, decrement. Right? And here, if the user clicks the plus button, we want to receive the message increment. And then here in the bottom, we just wire it all together. We use this HTML program, which is defined in one of the Elm standard libraries. It takes a record, and it wants a view function, an init function, and an update function, which is what we give it. And it also wants this thing called subscriptions, which I don't want to go into now, but which is basically for receiving regular events from JavaScript. Okay. Let's see how it behaves in practice. Oh, lo and behold, we have a counter. Now, if I click minus here a couple of times, one of the things that I want to show you here is that this is running in debug mode. So down here, you have this explore history thing. I hope you can all see it. I can move the window a bit up, further up maybe. And what this is basically just the log of what happened in the application, all the messages that we got, which here is a bit boring because there's just two possible messages and they don't have any payload. But you can just click on this and you can see that the counter reacts to this. So maybe let's make the counter a bit bigger. So you can see that if I go back, this is the first time I got a message, then we got another increment, and a decrement, a decrement, a decrement. And this is really nice for debugging. And you can also import or export these. So if you have testers and they do Q&A and they say, oh, the numbers can get negative, that wasn't supposed to happen. You're like, oh, I don't know how that could happen. Please send me the log. Then they can just serialize this, send you the JSON, you ingest it into your application. And it's super obvious what happened, and you can play around with this and fix it. Okay. But what is the actual behavior of, or the experience of developing in Elm? Let's start, and let's say business comes back and they say, okay, this like minus and plus buttons, they're really cool, but for our customer, we want a double plus button, right? Okay, so we say, sure, we make a double plus button, so let's make double increment, right? Okay, now let me save this, and let me save it like this, because what you will see is that, just like if it works, yeah. Just like maybe you know this from Go or something like this, there's an auto format, which just formats code always the same way, right? So maybe you know this from JavaScript, now it's getting popular with Prettier, or Go format in Go does this, which is a really nice thing because I can just read every Elm code because everyone uses Elm format, and it's always formatted the same way. Okay, what happened here? We get an error message, and again, the overlay is a bit small. I don't think I can easily make that bigger. But basically, the compiler here tells me, wait a second, the union type that you defined up here, it has 3 cases, but you're not handling double increment. And that's super nice because, yeah, I forgot to do this. So let's go in here and add a case for this. Double increment. And in this case, what do we want to do? Well, basically the same as with increment, but in this case, yeah, go away. But in this case, I want to add 2, right? Okay, save. Now it's gone. Okay, that's fantastic, but we don't see it anywhere yet, right? We don't render it. Okay, so let's duplicate this button here that we have there and do a ++. And save it again. And here we have minus, plus, and plus, plus. So now if we click plus, plus, oh, what happens here? Yeah, I sent the wrong message, so we need to send double increment, of course. Save. And now if we click plus, plus, then it gets incremented by 2. If we click plus, it gets incremented by 1. Okay, fantastic. Now business comes back and they say, yeah, this is fantastic. This feature you implemented, super. But now we want triple increment, right? And you're like, oh, come on, you know, really? But you think, okay, this is getting a bit silly, right? Making a single message every time for these things. Let's just give a payload to the increment action value, right? So let's say increment always carries with it an integer, which is by how much we want to increment it. Okay, we click save and kaboom, right? Something is wrong. So what is wrong? We click here and Elm tells us I cannot find the pattern double increment. Yeah, right, I've removed that. So let's remove this. Okay, save. What happens now? Still red. Okay, it says pattern main increment has too few arguments. Ah, this is also correct, right? I now said that increment always has to have a payload of an integer. Okay, so let's give it an x. And then, of course, we don't want to increment always by 1. We now want to increment by this value x. Okay, save again. And still something is wrong. Okay, double increment doesn't exist. Yeah, correct. Okay, let's remove this button and duplicate the increment. And now we need to pass in 2, right? Now again, I said this before, sometimes in Elm you have to use parentheses like this. In this case also, it's a positional argument. We need to tell it on click wants exactly 1 argument, so we need to use increment here with parentheses around them. And then we click save, and still there's a problem. Right, increment here in the place before doesn't have the number attached to it by how much we should increment it. So let's do this and save, and now we're good again. And now we have minus, plus, and plus 2, right? And that's a very simple example, of course, but this development experience, of course, it works across modules, it works across like other packages. It's just really nice, and it helps you develop with confidence, right? The code just tends to work. When it compiles, it works. And sometimes it takes a while to get it to compile again, because like when you refactor, like all kinds of stuff all of a sudden looks different. But the compiler just nags you until everything works out again. And this is a really, really nice thing that lets you sleep much calmer. There's also a really nice feature in that Elm can check the types of the packages that are generated, and then it can enforce correct semantic versioning. So basically when you do an update to a package and you change something because you rename a variable or rename a function, then the Elm compiler will say, hey, the types are different, this is a breaking change, you have to do a major version upgrade. The small caveat is, of course, that if you just do like, if you have a boolean and then you treat it differently or stuff like that, so these kinds of things it cannot check for you. But a lot of the like usual semantic versioning breakages that happen in like JavaScript packages, it can catch these because the compiler just knows about it. Okay, so time to slowly come to the end. Where do I have my thingy here? Okay, quickly, I just mentioned these commands in passing just to quickly show you how that works, because maybe you're still wondering how to do side effects. So for stuff like HTTP requests or generate random numbers and things like this, we need to use commands. And the basic way that this works is, as you see here, so send command, it basically constructs one of these command values. It uses the HTTP library to say, okay, when this command should be done, like dear runtime, please go and do an HTTP get string to this particular URL. And this is the second parameter to HTTP send in line 9. When this comes back, either like succeeding or failing, please send the loaded message back to my update function, right? And then in the update function, you have a case, and then you handle loaded either with OK, if it went well, with the text that you wanted to have, or you handle loaded with the error, and then whatever HTTP error, timeout, or whatever is captured in that HTTP error. Okay, ports. Okay, I see I'm running a bit low on time, so I'm just going to quickly go over this. Ports are basically similar to commands, but instead of talking to the Elm runtime and doing like things that are more or less pre-baked into it, ports are used to have, so you write your own JavaScript next to your Elm code, and then you can communicate with messages back and forth. This is useful if, for example, you want to play audio, which the Elm library doesn't support yet. Then you write a bit of JavaScript that uses the Web Audio SDK, and then you send a message through ports to JavaScript. The JavaScript starts playing, and then if you like, you can send messages back again. The overall experience of building production apps with Elm was super nice. We really never had runtime exceptions, which I think is really a fantastic development experience. The compiler helps you all the time, and you have this wonderful confidence in your code. You're not like, I need to push this, but oh my god, maybe it's going to break in production, and these kinds of things, right? So really great. Obstacles. Some of the things that are not so ideal. Sometimes you need to use ports for things that seem kind of trivial. For example, to move focus between several input elements, which is a bit annoying because in JavaScript it's like not even a one-liner basically, and in Elm you have to then set up ports and stuff like that. You can't at the moment publish native modules, so basically Elm modules that also have JavaScript accompanying it. But you can do that just with GitHub sharing code. And there is a thing when you use ports and you send messages back and forth, you not only have to define the types of these things that get sent back and forth, but you have to write what's called JSON decoders. These things are a bit tedious to write. In theory, for most of the cases, the compiler could do it for you, but for now it doesn't. Okay, I think Elm is absolutely ready to be used in production. It drastically reduces bug counts. The development speed, as I said before, it doesn't slow down as the project gets bigger. And realistically, you will probably have to maintain some JavaScript on the side, but I think that you still gain a lot if you can move the majority of your logic into Elm. If you want to learn more about it, there's tryelmlang.org, which is an online editor that you can use to play around with. On elmlang.org, you can get the compiler and all the links to the editor plugins and stuff like that. In the beginning, maybe try it for a side tool or internal tool, and go on the Elm Slack and ask questions. They're very beginner-friendly. Yeah, with that, thank you all for coming. And I'm Daniel Bachler. I'm DannyX23 on Twitter. And please ask questions and rate the talk. Thank you.
Yeah, we have some questions. One of them is, are there any non-trivial open source Elm applications that could be used to learn the style and idiomatic and stuff like that?
Yes, so if you go to elmlang.org, there's a couple of projects linked out, and there's at least some of them who have like a couple of thousand code lines or so. I don't know if there's any like tens of thousands or so open source projects yet, but there's definitely a few.
Then two questions about default values on models or parameters or on attributes. Mm-hmm. Is this possible?
Yes, this is something that I didn't have the time to go into it. There's something called partial function application that you can do in Elm, where basically you can have a function with, let's say, 7 parameters. And if most of the time you just need 2 of them, then you can make a new function based on this function with 7 parameters that has 5 of these parameters applied in a default way. So that's how you would do it.
Mm-hmm. Another two questions really about how do you structure or split an application, which is a bit more complex.
So this is an interesting point. A lot of people coming from React or similar other UI frameworks, they think in components, right? So there's a visual component and they think like, okay, this should have its own update and its own view and its own init basically, which you can do in Elm. So you can do this kind of structuring, but usually it's more idiomatic if you just try to create different functions, and then maybe you have this one thing that renders like an abstract of a person, like first name, last name, whatever, GitHub repository count or whatever, and then maybe you just have a function that renders this given a certain kind of data, but you wouldn't necessarily have its own update function and these kinds of things. Again, this is a bit of a bigger topic, so because it's a bit of a mind shift, but you can absolutely structure your Elm applications in a similar way, but it's usually nicer if you just think in functions first.
How about using other frameworks like Ember, XJS, and something like that in Elm?
You can't do it. So the Elm is really tied to its own implementation of the virtual DOM. So it works basically similar to what React does, and that's the only way you can write code in it. And basically in Elm you live in your like own little bubble, so there's no directly calling out to JavaScript in any form, which is what makes it possible to give you all these guarantees on the other hand.
Another question, I just read it. It's been a while since the last major release of Elm. When will be the next release, and will it support server-side rendering on Node.js?
Yeah, I don't know. I mean, it's definitely actively developed. Evan isn't the creator of the language, who's like the main developer on it, isn't very keen on publicizing any deadlines. We know that he's working on it and he has been for a year. It's probably gonna be soon-ish. Whether it's going to be this year or like Q1, nobody knows. Server-side rendering was said to be in his like focus. Whether it will be a nice language to develop for Node, I'm not so sure for now, because it's just like very much made for creating browser apps at the moment. But there is some support hinted at for like at least like rendering the initial like basically HTML that you could serve to a non-JavaScript enabled client.
And then also one, well, in this track at least, inevitable question, a comparison question. Can you compare it a bit to Elixir?
Yeah, that's very different. They're often used side by side, because Elixir, of course, is a server-side language, right? And it has a great concurrency model, whereas Elm doesn't have any, basically, right? I mean, it has a like concurrency model through this update cycle, but Elm is very much like focused on writing user interfaces, like basically inside the browser, right? Whereas Elixir is something that runs on the server and is very good at like handling like a lot of processes that communicate with different endpoints and stuff like that. But as I said, they're often used together. So in the company No Red Inc., where Evan works, who develops the language, they use both of these languages together.
Okay, the others have probably been answered already in the end of your talk. Any other questions in the room here?
Okay.
Yeah, one.
What's the common use case of Elm? Can you just replace any Java application, for example, or what's the?
Yes. So basically, everything that runs in every JavaScript that runs in the browser and doesn't have like external dependencies that you need to bring in is a good candidate to replace. So basically the majority of web applications, if you start building them now, or if you rewrite something that you have, I think Elm would be a good candidate. The caveat is if you have a lot of like experimental web APIs that you use, like WebGL plus Web Audio and so forth, at some point maybe you spend most of your time like sending messages through the ports to your JavaScript that you also have to maintain, and then you have to make this trade-off, does it make sense? But for a lot of like the normal kind of business, just display a couple of forms, like make validations, these kind of things, I think Elm is a fantastic language.
Okay, last question.
Thanks. It's actually my second question, because I asked one online. Very nice talk. One thing I want to ask, and I find it difficult also in Redux, how do you work with the front-end team? Like, they have to learn these strange definitional views. Is that something you mitigate somehow?
So we had this experience when we did our production app. We have one developer who is mostly responsible for styling and designing. She does have some Python experience, so she's maybe not your typical like entire just CSS person. But she was into it and she liked it, and it like. As I said, like it takes a few days for your eyes to accommodate to this like kind of writing, like basically HTML again. But it's totally possible, and I think that if you invite them and like try to explain these things, like we can write bug-free software if we do it this way, that they might very well be open to adjusting to a different kind of doing it.
Writing bug-free software is a very good thing. Okay, thanks a lot.
Thank you.